Okay, so cotangent is, what do we do to get cotangent? What do we do to tangent to get cotangent? Tangent is the reciprocal, cotangent, the reciprocal of tangent. So we're going to look at our unit circle, and when we were doing tangent, we were using the first value and the last value of the places that were undefined. So what I'm going to do is I'm going to find where is cotangent undefined on the unit circle. So we need to know, let's see, tangent is what over what? Y over x. And in the video, it was said that it was a sine over cosine. Either way, either's fine. So cotangent is what over what? It'd either be cosine over sine or x over y. So if I'm looking where it's undefined, then what value of y am I looking for?
0.
Yeah, 0. So up here in the unit circle, where is y 0?
Coordinate.
At what radian? Okay, at 0, that is the ordered pair 1, 0. And where else? At pi, and that is the ordered pair negative 1, 0. So those would be the two locations where cotangent would be undefined. So when I start my table, I'm going to start at 0, and I'm going to end at pi. And after that, it's repeating. That's going to be one cycle for cotangent. So if I have from 0 to pi, what is the middle going to be? Pi over 2. Yes. Yes, 90 degrees. Pi over 2 is up here. That is the ordered pair 0, 1. So what is the value? Let me fill this in real fast. What is the value of cotangent at pi over 2? 0, right? So we're doing x over y. We're doing 0 over 1. So now I need what's in between those. So what's in between 0 and pi over 2? Pi over 4. I feel like changing colors, so I'm going to. So that we need to know what the cotangent of pi over 4 is. Well, that's going to be the reciprocal of tangent at pi over 4, which we should know already. What's the tangent at pi over 4? One. So then what's the reciprocal of that? 1. So at pi over 4, 1. Where else do we need? 3 pi over 4. So that will be here on the graph. And that one's going to be negative 1, right? So you look at the order of the numbers, it's different than tangent was. So we really just need to be careful when we are filling out our key points. So on the quiz, I'm not giving you the x column. I did on your homework, but on the quiz, I'm not going to. So you have to know which x column to use for which kind. And tomorrow in class, tomorrow in class we'll practice that without the x column. All right, graphing it, we're going to graph our asymptotes. And then we're going to follow the pattern. So how far apart are these asymptotes? They are pi apart. So every pi. And since I'm doing my asymptotes, I might as well go ahead and fill out that part. X equals, what's my first asymptote? 0. So I'm not going to write it. You can. I'm not going to. And then what am I adding on each time? K pi. Where K is an integer. as well do my domain. How about my amplitude? 1. It's just a parent function, so we don't have any special things happening. Amplitude's 1. I'll do the range and the period after I graph the rest of the points. So graph those. We got pi over 4 as 1, pi over 2 is 0, 3 pi over 4 is negative 1. This is what I've had some conversations with certain individuals about connecting them. You want to think about the center point kind of being like a vertex on a parabola, and draw half of a parabola. It's not a parabola, but it's kind of like it. And then the other direction, think of it being a vertex and a maximum parabola where it opens down. I just have some people putting their bumps the wrong way. And it is important that you can follow the pattern. So you do need to keep going. So with our range, what is the lowest point? What's the highest point? Negative infinity to positive infinity. And then our period would be, how far is one cycle? And you look up here and you see I've drawn 4 of them, 4 of the same thing over and over again. How far apart is one of those? Pi. So I didn't give you a formula, which there is a formula, and you can look it up or figure out the formula. I didn't give you a formula for period, because I want you to know what it means. I want you to know it's how long is one cycle. After this, the other 3 examples are using this parent function and using transformation. So I'm going to give you some time, and you're going to do the other 3 examples before you start your assignment. Your assignment is shorter because we're doing examples in class. That's why your assignment is shorter. And if you have any questions, you're going to come out or call me over and ask me. If you don't have questions, I put the answers to the other 3 questions right here. And I want you to get out of your seat and stretch your legs and look at the answers as you work on the next